said, hi, I'm Emily, and this summer I interned with Ducommun Aerostructures in Parsons, Kansas. So just a quick overview of the company. They were founded in 1849 and are headquartered in Santa Ana, California. They produce various products for applications in commercial aircraft, military, and space programs. And in 2023, they had an overall revenue of about $757 million. Specifically, the Parsons location, located right where this little pink star down in the corner of Kansas is, right there. They specialize in metal fabrication for structural systems, and they're capable of producing over 4,000 unique parts in the facility. And one unique process that they have is the hot and superplastic forming of titanium, where the titanium parts are heated to over 1,200 degrees to be formed into whatever desired shape the part needs to be. So quick overview of some pollution prevention. So Ducommun's pollution prevention focus for me this summer was looking at chemical and hazardous waste reductions, GHG reductions through power consumption reductions, as well as improved health and safety through toxic release reductions. And for waste management, I tried to keep my focus within the top 2 tiers of the waste management hierarchy. So I looked a lot at source reduction of the chemicals or reuse of chemicals as well. So a quick process overview. Every part kind of goes through a little bit of a different process. There's no one specific assembly line type process for all the parts. Everything's a little bit different, just depends on what's specified for the specific part that they're producing. But this is just a quick overview of one possible process that a part could follow through the facility. And I kind of kept my focus within these couple of different processes. That's where a lot of the chemical usages and the energy consumption. So over the course of the summer, I worked on about 7 different projects. So I looked at replacements for the masking used in the facility, as well as some of the chromium primers. I did an examination of gas and electric power in terms of power consumption. I looked at reduction of chemical waste as well as chemical inputs, looked at water use reduction as well as reuse for some of the garnet abrasive used in the facility. So the first project I looked at was a replacement for their masking. So currently they're using a solvent-based masking that's about 50 to 60% toluene and 10 to 15% xylene. And both of these are hazardous air pollutants. And because of how much is being emitted per year, they have a potential to emit over 25 tons combined of these HAPs. And that is currently keeping them within a Title V air permit. But if this were to be reduced below this value, they would be able to get out of that Title V air permit, which would save them about $600 a year because they're not paying the $3,000 renewal fee every time they have to renew the air permit. So I proposed a couple different solutions. So I found a company that produces UV curing maskings. The main issue with this is that there would be the capital investment of purchasing a UV curing oven or some kind of UV curing system. And these options were quite a bit more expensive than the other option I looked at. So that also proved a little bit of a problem as well. And I also looked at a water-based masking from their current supplier, and either of these options would completely eliminate the toluene and xylene by about 13,000 pounds of toluene per year and 3,000 pounds of xylene. And so here's kind of a quick comparison of all the options I looked at. As you can see, these two in the middle are the UV curing ones, and they would be a lot higher of a capital expense operating cost. But these two also cure quite a bit faster within minutes versus the hour that the other alternative would take. So based on that, the improved efficiency could help kind of mitigate that cost. I do recommend replacing the masking, but a little bit more research would be needed to figure out specifically which one should be used as the replacement. So next, I looked at an examination of the gas versus electric power. So in the winter, their natural gas costs are much higher than in the summer months. And this is mostly due to heaters that are placed throughout the production floor to help keep the facility warm, since it's not climate controlled, so when it gets cold outside, it's going to be cold inside. And so there's a lot of natural gas going per year to power these heaters, as well as some boilers that are used for like air conditioning purposes to keep climate controlled areas at a certain temperature. So this is where a lot of that natural gas usage is coming from. So my proposed solutions here, I looked at a couple different ways to reduce this. So I looked into replacing the gas-powered appliances with electrical power. So I looked at both the heaters and the boilers. So the heaters would have saved $10,000 a year in the amount of therms that it would reduce. However, with the high capital costs for purchasing new electric heaters and everything like that, there would be a 16-year payback, which seems like not really a viable option. And so I looked at the boilers because there would be less of them to replace. So I thought that maybe the capital cost up front wouldn't be as high, so it'd be a little bit more worth of replacement. That had a 13-year payback, so it's not much better of a solution. I also looked at possibly finding a way to reuse waste heat from processes in the facility and convert this into power to try and save some energy spending and use this to power different appliances. So it would use an organic Rankine cycle system where it would draw in the waste heat and then use a turbine to convert this to power. But these systems are typically only like 10% efficient, so there would be about 60 kilowatts of recovery from the system, which would save $9,000 a year on natural gas spending. But the cost of the system would make the payback period over 200 years. So this is at this point not really that feasible of a project to implement. So the next thing I looked at was a reduction of chemical waste. So there are two chemical milling lines in the facilities. One of them has a connection to reactor tanks so that the wastewater can get treated from the low pH that it's at up to a safe level to go back into the water supply. But the smaller chemical milling line does not currently have a connected reactor, so that the wastewater here does not get treated, and so all the wastewater has to be sent out as hazardous waste because it is not at a safe pH. And that's about 11,000 gallons a year of extra hazardous waste just from this untreated wastewater. So the solution here pretty much is just connect it to the treatment tank to treat it ourselves, because sending the water to get treated as hazardous waste is treated through the same process that would be used in the reactor. So it would just be more beneficial to not be spending that money on waste disposal, and it would save about $45,000 per year on hazardous waste disposal for that extra waste. So the next thing I looked at is there's also a lot of chemical usage in the facility, and the chemical milling lines, the titanium builds up in the chemicals, so they have to pump out the tanks roughly on a weekly basis to be able to lower the titanium level a little bit, and then they have to add in more chemicals to make sure that the etching rate doesn't get compromised by the amount of titanium, because that can change how the process works. And so they used to have this system in place that would filter out the titanium pieces using a resin that would pull the acid through the pores and make it elute out slower, so that the titanium pieces would kind of exit first and be able to be separated from the acid. But the system stopped working and it hasn't been functional in like 6 years. So currently they just have to pump out and add in more chemicals. So the proposed solution for this would be to replace the system, but currently there are no systems commercially available for this. So it is tentatively recommended, but there's not really anything that can be done for it at this point. But if a system like this were to be implemented, it would save $272,000 per year. So it would definitely be worth it to make the investment of getting a system to reduce this amount of hazardous waste, as well as save on input chemicals that go into the chemical line. So then the next project I looked at was a reduction of water usage. So for the hot forming processes in the facility, they are running on a 24/7 operation because of how high the temperature is. It would take too long for them to heat up if they were turned off and turned back on. So there's a cooling tower that is used to help like keep them cool so they don't overheat or anything like that. But the current cooling tower they have is too small for all 12 of the presses. So the largest press right now is just has a stream of water from the city constantly running through it, about 11 gallons per minute, which is about 30% of their overall yearly water usage. So that's a lot of water that's being used for this that could just be coming from a cooling tower instead. So there were a couple different solutions I looked at for this. The first one was just to get a new cooling tower that could support this capacity, and this this project is actually already in the process of being implemented. There's a plan they already had in place. So my work on that was more just to kind of justify the spending on that, and it would save 6 million gallons per year, as well as about $90,000 per year on spendings on water. But I did also look into possibly using a thermodynamic cycle for cooling, and that would just completely like eliminate the need for having the cooling towers. So it would work similar to like an air conditioner. It would pull in the heat from the presses and then send that outside while using a fan to put cooler air to kind of keep the system a little bit cooler. But the amount of power that would be required for the amount of cooling needed, the cost to purchase that system, as well as the yearly cost for extra power that would be used to power it, was greater than the amount of savings. So there would be an extra operating cost without any savings to back that up. Okay, so then I looked at replacing some of the primers used in the facility, which, like Sarah said earlier, aerospace is very strict about that, and the hexavalent chromium is required in basically all of the customer specifications, but it is highly carcinogenic and could pose serious health and safety issues to employees who are exposed to it repeatedly too much. So I looked to see if there was any way to find chrome-free alternatives for any of the primers that are used. I was able to find one of the customers has a specification specifically for like they had a classification for non-chromated primers, and so there's a possibility that we might be able to change from the current primer to one that's non-chromated, and this would have to be proposed to the customer for them to approve before it could be implemented, but it would get rid of that hexavalent chromium. It would improve the health of workers as well as reduce some toxic emissions to the air. Both suggestions I found for this were more expensive, so there would be no savings on the cost, but the improved health benefits would kind of outweigh that. So I suggest this one just because it's the cheaper of the two options I looked at. Okay, so my last project looked at reuse of the garnet abrasive used in the facility. So I looked into finding some kind of recycling system for this, and currently there are systems available for dry garnet from like an abrasive blasting process, but I couldn't find anything for water jet garnet just because it builds up into like a wet sludge and it's harder to kind of pull the garnet out of that. There were systems back in like 2016 I could find from a couple of companies. I couldn't find any recent information on them, and I reached out to one of the companies and never heard anything back about it. So I don't think the systems are currently still available. So the problem with implementing this would be that a system for that doesn't currently exist, but those typically would use about 50% of the garnet because about 50% of what goes through the stream of water in the water jet does not get used for cutting, and so it's still of a size that could be reused, but it just all gets disposed of to the landfill, and it would save them about $17,000 per year because they'd be purchasing less garnet. I also briefly looked at possibly changing the material to reduce some of the garnet that's being used, but most other alternative materials are either too soft and would not be as efficient in cutting, or they were too hard and would leave not as clean of a cutting edge finish, and that would potentially hinder the quality of the parts, and that's not something that they really want. So this is a quick summary of all the projects I looked at. So overall, the recommended projects would save them about $133,000 per year and would reduce CO2 emissions by 34 metric tons. And then I do have a couple of projects I recommend for looking at in the future. I think there is some potential behind the waste heat to power conversion project. It's something I started looking at later in the internship, so I didn't really have a lot of time to explore too deeply into this concept. So I think that'd be something beneficial for a future intern to maybe look at and see if that would be a good project to implement. And then also just looking into green electricity sources. I know previous interns have looked at solar power and that kind of stuff, but I think that would help reduce some of the power consumption from traditional sources and would put less strain on like the power grid in Parsons, and that would help reduce costs and emissions as well. Thank you all for your time. Any questions? Yes.
Even if not a chemical building, it's like where you have the waste, you're trying to reduce it.
Yeah.
So I had a question on that. The hazardous waste that's being messed with, do you know if it's only hazardous waste because of its pH, or is there anything else?
It's a mixture of water at a low pH and hydrofluoric acid and nitric acid.
Okay, gotcha.
But there's like some of the water is not getting treated. So that's like, yeah.
The only reason I bring it up is if it was hazardous waste or something in addition to pH, then technically they're trying to treat it and make them a TSDF that brings in a full stuff.
So I was curious about the cooling tower. Can you just briefly explain how that works?
What specifically did you was the question?
Just like what's the process like for a cooling tower? Is it? I've never seen one.
So my understanding, I think the cooling tower would cool the water, send it through the system. The water would get heated up by like what it's trying to cool. So then would come back. So the cooling tower cools the water to whatever temperature is needed to like cool down the presses.
Is it just so? Does it use any sort of refrigeration? Is it just cooling by waiting for something?
I don't know.
It generally uses
Evaporation. Okay.
Yeah, so it depends on the size of the cooling tower.
I didn't look too much into the process. So.
Yeah, no, I was just curious because I've never seen one. Is it a big tower? Like
tower.
Is a tower? Tower.
They come in all sizes, so there's probably some on your roof for HVAC.
Yeah.
And really it's just a process that you cool down your process water through, and all the way up to the size of cooling towers for 3 mile. All chambers.
Oh.
Yeah, that's a source of winter time. That thermal energy in the facility just.
That's a good idea.
Possibility to look at the future.
I guess my question is kind of like the same thing. Are there any potential avenues where you can reuse some of that heat that would otherwise just be used to evaporate? You know, is there some like output water that's left behind that's hot water that you could recycle?
Not sure about that. The heat would probably fall under the waste heat to power concept that I discussed a little bit. So there's probably is more research behind that that could be done for determining if that heat that's coming off it could be used.